Welcome back, everybody. In our next section, we're looking at segment routing with ISIS, which is going to be very similar to the behavior of OSPF, but of course the command structure is going to be a little bit different when we're dealing with one protocol versus the other. Okay, so first we'll look at how do we configure ISIS with segment routing, or excuse me, segment routing with ISIS, and then the second portion is going to be how do we verify that it's functional. Okay, now just like OSPF, it's going to be two discrete steps. We go to the connected prefix SID map. This is going to be what is the loopback that we're advertising, and what are we mapping the label to. So we take the default sRGB, that's segment routing global block, starts at 16,000. We add an index number like index number 1 for router 1. That's going to be the label value that it's using. Okay, second portion is that we need to go under the ISIS process, and then we need to turn segment routing on. Now, since ISIS is using the type length values to encode the segment routing information, just like MPLS traffic engineering, this means that you also need to enable wide metrics under the ISIS process. This is part of the adjacency negotiation. So if one router is running metric style narrow and the other is running metric style wide, then they won't be able to communicate. So if you have a case where you still have legacy boxes that don't have this command on for whatever reason, you can run metric style transition in order to support both of them at the same time. But otherwise, be careful with this. You don't want to accidentally cause an outage because the metric style is not in agreement between the routers. Okay, so first on iOS XE, we have nearly an identical config to OSPF. Only difference is that we're going under the ISIS process, turning metric style wide on, and then enabling segment routing. But in terms of our syntax here for the actual connected prefix SID, or the node SID, we're saying that this prefix has an index value, meaning we take 16,000 plus the index, and that's going to be the label value. So we're saying to get to 1111/32, I want everybody to use label number 16,001. Okay, from an iOS XR point of view, likewise going to be pretty similar to OSPF. So we have under the routing process, metric style wide, segment routing is on. Then under the loopback, we're specifying what is the prefix segment ID. So again, we could use the index or you could use absolute. Same result here, but it has to be within that segment routing global block. Okay, from a verification point of view, as usual, ISIS does not have as many verifications as OSPF does. So we'll look at just a minimal number of these here, show ISIS neighbor detail, show the ISIS database, and then show ISIS segment routing. Hopefully it's going to give us some more information about what's going on. But otherwise, likewise in iOS XR, not too many verifications because this feature is so new. Okay, so again, same topology. We're trying to get IP reachability between router 6 and router 7, and they are layer 3 VPN customers of the 4 provider edge devices. So let's start on the bottom on our regular iOS boxes. Let's start on router 1 and just look at the current topology. So if we look at just show IP route, okay, so we see that we're running ISIS level 2 routing. So we have a route to router 2's loopback, router 3's loopback, and then hopefully 11, 12, and 13, which are the iOS XR boxes. Okay, so we already have a route to everyone's loopback. That's good. Okay, next let's look at the show MPLS forwarding table. Okay, right now the forwarding table has some labels because we're running LDP. So if we look at the show run section ISIS, we have MPLS LDP auto config under router ISIS 1. And result of this is that customer router 6, when we ping to 7777 source 6666, we have connectivity, and if we do a trace route, we should see that we're following the label path. Okay, notice that the transport label is getting swapped on each hop where the VPN label is staying the same. Okay, so next we're going to configure segment routing. Okay, so again, for our iOS box, we're going to go under the same segment routing mode as we had done in OSPF. Okay, so globally, we have segment routing, our segment routing MPLS. Okay, what is the connected prefix segment ID map? Address family, only IPv4 in this particular version. And then we have 1111/32, which is our loopback. And let's say in this case we have an absolute value, 16.101. If we show run section segment, okay, let's take this same config, and then this is going to go to our other XE boxes. Okay, so this should say we need to stop there. Let's get rid of exit address family. Okay, so we're not advertising router 1's loopback, we're advertising 2222/32. Absolute value is 16.102. Okay, similar config on router 3. It's advertising 3333/32, absolute value 16.103. Okay, last step though is that we need to enable it under the routing process. So under router ISIS1, we simply say segment routing for MPLS. Router ISIS1, segment routing, MPLS. Okay, same on 1 and 2. So router ISIS1, segment routing MPLS. Router ISIS1, segment routing MPLS. Okay, if we now look at the show MPLS forwarding table, we have multiple labels. Okay, this one says M. Does it give us a, it says that is merged. Okay, that's the LDP label. Okay, if we look at the show, let's see, show, let me go back to my verifications here. There we go. Which is show ISIS segment routing. That's what I'm looking for. Okay, show ISIS segment routing. And I want to know which is preferred, LDP or segment routing. Segment routing label preferred is disabled. Okay, so this means since LDP is already running, there's going to be no change from the end client point of view, the end customer point of view. They're still going to be using those previous labels that were bound through LDP. So let's go to router 6 and do our trace route. Nothing changes here. Okay, there were some, well, actually we're doing multipath. So we chose different hops on the first and the third here, but notice it's still the same labels, 24003 and label number 17. Okay, so let's go ahead and turn LDP off. So this is going to be under router ISIS1, no MPLS LDP auto config. Router ISIS1, no MPLS LDP auto config. Router ISIS1, no MPLS LDP auto config. Okay, if we now look at the show MPLS forwarding table, we do still see label numbers. Okay, it says to get to 1111/32, we use 16.101. So now, as compared to the previous output, we're preferring the segment routing label simply because LDP is not running. Okay, otherwise there is a command there to say segment routing is preferred over LDP. Okay, so let's look at this from the customer's point of view when they do a trace route. We see, well, let's do this. Let's take the multipath out. Okay, so temporarily, let's go to router 4. And router 4 on gig 2 411 is going to say shut down. Okay, so let's trace from 6 to 7. And let's see, which way is 1 routing? Well, let's continue with the config on XR. Okay, so the XR config is going to be only under the ISIS process. So under, actually let's show run router ISIS. Okay, router ISIS 1. We have under address family IPv4 unicast. And we're assuming metric style wide is already configured. Okay, which it is. Okay, we're going to turn segment routing on. And we're going to turn, oh actually no, that went to a different mode. Segment routing MPLS is I think what we needed to say. So let's go router ISIS 1, address family IPv4 unicast, segment routing MPLS. Okay, then we have under the loopback, under IPv4 unicast, we have our prefix segment ID. Okay, so we'll say absolute here is 16.1.11. Okay, last bit we're going to add is to turn LDP off. No MPLS LDP. And that's under what? Under the address family. No MPLS LDP auto config. Okay, let's commit, and then this is very close that we can copy and paste to the rest of the other XR boxes. Okay, so on XR2, prefix SID is going to be 16.1.1.2. Commit. On XR3, 16.1.1.3. Okay, next let's look at the show MPLS forwarding table. And we're mainly looking for the loopbacks. Okay, so router 1's loopback is 16.1.1.1. Router 2 and router 3 were directly connected to them. Router 11 is 16.1.11. Okay, so it looks like we have the correct values. Then we have our adjacency SIDs. These are going to be the ones that are for the directly connected links. Okay, now finally from the customer's point of view, if we trace through, let's see, why does 1 not have connectivity? Okay, so let's check from router 1's point of view. Let's take a look at the diagram. And let's ping inside, actually let's ping loopback to loopback first. So let's ping 111 or ping 3333, source 1111, and trace this. We should make sure that it has the label path, okay, which it does. Let's see though, something is wrong in terms of connectivity. Ping 2222, source 1111. Okay, so let's do this. Show VRF. So VRF is named B. Let's ping in VRF B to whatever the address is on the other side. On router 3, let's show VRF, show IP route VRF B. And this local address is 10373. Okay, so that works. So it's not an issue with transport over the core. Oh, it may have just been converging that long. Unless, is there some sort of routing loop? Well, either way, let's not get hung up on this because this may be a problem in virtualization. We can see, though, that the labels are being bound. That's really the ultimate key point, and that they're in the label forwarding information base. So when we look at the show run section segment for segment routing, we're saying we're using 16101 as our particular label. And if we were to do a trace route through the core, so let's go ahead and capture this. So let's go on router 2, interface gig 2, and we're going to traffic capture. Then let's do that same ping we did before inside the VRF, and look at this from the capture's point of view. So what we should ideally see okay, let's look for ICMP. We should ideally see the segment routing label, which we do. So we're going from router 1 over to router 3. It says to get there, use 16103. Then on the way back, when we're going from 3 to 1, we're using 16101. Now, if there were more than 2 hops in the middle, we would see that 16101 would be preserved and 21 would be preserved. Because now in this case, both the node SID, which is again coming from the segment routing global block, is globally significant, as well as the VPNv4 label that's always globally significant to the BGP network. Okay, so from a verification point of view, in XC, let's look at the show ISIS neighbor detail. And it says, what is the adjacency SID value? Okay, this I'm not 100% sure how this is encoded. But at least you can tell that they are running segment routing, right? Okay, what else do we have? Show ISIS database verbose. Just as usual, ISIS doesn't have as many good verification commands as OSPF does. So segment routing, here's our sRGB, and then it goes up to whatever that is, 16,000. Plus what? Plus 7,999, 63999, because it's plus, it's 8,000 inclusive, because you can there is a 0 value for the labels. Okay, so about to 24,000. So SID value 36. I'm wondering, maybe this is, let's see, is this in hex? And why is my calculator so ginormous? I have no idea here. Can you zoom it back in? There we go. All right, so what is 36 in, no, I need to say hex 36, right? Well, nope, that's not how it's encoded. Okay, but anyways, somewhere in here, this is what it's saying what the label value is. And then what else do we have? Show ISIS segment routing. So connected SIDs, there we go. So this would be easier to look at. This is show ISIS segment routing connected -SID. This shows what are the, oh, actually, you know what's going on? I think those, did I accidentally copy and paste those multiple times on the XR boxes? Show run. Okay, so under ISIS, we have metric style wide, segment routing, MPLS. Then under the loopback, address family IPv4 unicast, and then prefix SID, either an index or an absolute value. Okay, then final result of this, we show MPLS forwarding table. We see that we're using those label numbers, 16113, 16103, in order to get to the final destinations.